In this video, I'm showing you how to create this trajectory line using a line 2D. I'll show you the code to compute the path, how to draw it with a line 2D, texture it using a repeating texture, and finally, a simple shader to animate the texture. Let's start. In this tutorial, I have set up a main scene with collisions for the floor and the wall, and then I have a little shooter thingy that shoots projectiles. I'm going to show you quickly how the projectile is moving, as it's important to draw its trajectory. As always, you can find the whole project on GitHub. Link in the description. The projectile is a simple kinematic body 2D with a square collision shape. If we look at the code, I define its velocity in the ready function using a direction vector multiplied by the speed. The direction vector is set by the shooting thingy when instancing the projectile. In the physics process, I add gravity to the velocity y component, and then I make the projectile move using move and collide with the velocity. If we have a collision, I bounce the velocity using the collision normal. This is to make the projectile bounce everywhere. I multiply this by 0.6 to dampen the velocity every bounce. Now let's look at the trajectory code. The code is greatly inspired by KidsCanCode tutorial on the subject. If you want to take a look at the written version, you'll find it in the description. I'll explain it quickly. First, we define the maximum number of points that we are going to compute. If you go too high, it might take too long and thus endanger your game's performance, so be careful. The higher the number, the further you'll compute the trajectory. We start with a position of 0 and we define the velocity that we're going to use using the direction multiplied by the speed, similar to what we were doing with the projectile. Then we iterate over the number of points we defined. First, we add the point to the line 2D, the first point being vertu2.0, the position of our shooter. Then we're basically doing the same thing as with the kinematic body. First, we apply gravity, then we compute the position, adding the velocity multiplied by delta. The code here is simple because the projectile motion is super simple. If you're doing more fancy stuff with acceleration and friction, for example, you'd need to update the trajectory calculation with those two. With that, we already have a trajectory that works well. The only thing is that it doesn't take collision into account, and we're going to fix it now. To handle the collisions and update the trajectory accordingly, we're going to use a hidden kinematic body. For that, add a kinematic body with the same collision shape as your projectile and change the physics layer and mask to a different one than the projectile to make sure that they don't collide. Of course, you need to have the same layer on the objects you're trying to detect collision with. In my case, I put the hidden kinematic on layer 3 and I have this layer also on the walls and the floor. Now, every time we calculate the next position and velocity, we can move the kinematic body to the right position and use the velocity in the trajectory calculation. In move and collide, we are going to pass through to make sure that we are in test mode. This means the body is not moved and we only get the result of the movement, thus the collision if there's one. If there's a collision, we bounce the velocity the same way we did in the projectile and we'll use this new velocity to compute the next position. As you can see, handling collisions is not that hard. Of course, you need to adapt the calculation to what you want. In this case, I'm bouncing off the walls, but you might want to stop or fall down, whatever you want. Our line looks a bit simple right now. If this suits you, you can stop here, or just use a gradient texture on the line 2D node. I'll add a tiling texture to go along the path. To do that, you need to create a repeating texture first. In my case, I use Affinity Designer to create the texture. To make it repeatable, you can duplicate your shape, cut it in half, and place it on one side of your texture area and the other half on the other side. To make sure that the texture tiles correctly in Godot, it needs to be oriented horizontally. If you have a texture tiling vertically, it won't work. Inside Godot, click on the texture and in the import tab under flags, make sure that repeat is set to enable and click re-import. Now you can place the texture under the line 2D and under fill, choose tile for the texture mode. And voila, your texture will now repeat correctly along the path and dynamically. You can change the width to make it bigger, and of course, the width curve will also apply if you have one. To animate the texture, we can use a simple shader. Don't worry if you're not familiar with shaders, it will take 3 lines of code. Under the line 2D node, under material, create new shader material. then click New Shader. At the bottom of Godot, there's now the shader editor where we'll write our code. First, write shader type canvas item. This is to tell Godot what the shader is. In this case, canvas item is to write 2D shaders. Next, we're going to write our code in the fragment function. I won't go into the details, but you have two built-in functions, fragment and vertex. Fragment works on the pixels and vertex on the vertices to deform them, move them, etc. In void fragment, we'll first sample the texture using vec4 inText is equal to texture UV. Texture is a built-in function to get the color value of a texture using a 2D coordinate. Texture is the texture of the object we're working on. In this case, the tileable texture we've created earlier. UV is the 2D coordinate of the pixel we're working on in this texture. This code returns us the color of the pixel. Then we can use this color to put it in the output of our shader, which dictates the color of the pixel we're working on. Color is equal to inText, does this. As you can see, our shader is working, but it's doing nothing because it's simply reading the texture and outputting it exactly as is. To make it move, we can simply play with the UV, which represents the coordinate of the pixels we're sampling. To make it move over time, we can use the built-in number time. If we simply add time to UV, it's going to affect the X and Y components. It's not what we want. In this case, I only want to affect the X component. This is simple enough, replacing it with UV plus vec2 time times UV.x, UV.y. That way, we only affect the X component. And with that, we have a moving texture along our line 2D. You can, if you want, add a factor to time to reduce or speed up the scrolling. If you want to access this value outside of your shader, you can define uniform float scrolling speed is equal to 1. At the top of the shader, the keyword uniform makes it available outside of the shader. You can then set it through code or in the editor directly. We now have a very cool trajectory line taking collisions into account with a cool repeating texture. Make sure to like and subscribe if you like it. See you in the next one. Bye.